Okay, I got some territory to cover here, so I'm going to jump right into this thing. We're going to be talking about fact-finding missions and a little bit of troubleshooting stuff with some stories along the way, and I'm hoping you'll get something out of this. We're going to define a couple of different kinds of primary errors here. A hidden conclusion is the search for reality. If the problem that we were trying to find in our troubleshooting quest wasn't hidden, then we wouldn't need to be investigating it. That's just the way it is. And so whenever we get under the hood, whenever we're looking for something, whenever everybody knows that whenever you're trying to figure out what's wrong with one, you've got to gather as much data as you can from as many sources as you can on that specific vehicle. You know, as much as we like to type in something into Identifix and just go find a silver bullet, there's a lot of the time whenever you'll get misled by that. So it's a good idea to be able to know how to find the problem yourself whenever everything else has failed, or I like to try to do it first, you know, before I go digging too deep looking for somebody else's solutions. Now, sometimes we just know what's wrong. If you've seen the problem enough to where you know what it is that's going on, like on these Chevrolet fuel tank sending units, this friend of mine called me about his 2007 Silverado, and it had the gas gauge had quit working right, and because of the fact that it was the vintage of GM vehicle it was, I knew that I had seen a lot of these wear out. This is actually the sending unit from his truck, and if you go to the Chevrolet place, you can buy just the sending unit part of it if you want to for about $145. We put one of those in there, and he was a happy camper, and we sent him on his way. It worked really well. We always like to pull the bed off when we do one of these because it's a little easier than dropping the tank, you see. Alright, so intelligent investigation is something that we have to approach this like we're a private investigator. You remember Calvin and Hobbes was funny, you know, he would have those little things where he was masquerading in his mind as Tracer Bullet Private Eye, and he would they'd show him with a wrinkle on his forehead and a fedora hat on his head, his feet propped up on his desk, and he would say, "I'm a private eye. It says so on my door. What I needed was a clue and a drink. One of these I knew where to get." You know, that stuff was always incredibly comical. Well, to find the truth, the investigator, we're the investigator, has got to gather and analyze data so that our investigation leads us to the conclusion we're looking for. What we're basically looking for is the truth. We want reality. We want something that's going to actually lead us to what it is that we need to do to straighten this problem out. All right, the diagnostic process requires we know enough about what it is we're working on so that we can make intelligent decisions and we're not just shooting in the dark, even in our thinking, you know. Okay, so second, we need to know how to gather the data in the right way. We need the right tools, we need the right skills, we need the right understanding to be able to pull the stuff up that we need to. We're going to put this stuff on our, you know, think of a in these detective shows, they have a murder board. They have a big board up here, and they put the pictures of all these people, and they draw these arrows, or they'll pull the little felt string from one pin to the other on the map and all that. Third, we need to know how to interpret the data that we've gathered. That's part of it. We need to be able to, once we've gathered all that data, if we don't draw the right conclusions from it, we can wind up moving in the wrong direction. Jennifer's oil leak, when we worked on her car, we gathered data by looking for the leak. That's the best way to do it. Some people like to take, you know, most people don't do this, but if you're looking for an oil leak, if you'll just paint the whole thing with foot powder, that white foot powder, and then crank the car up, a lot of the time you'll see the oil leak instantly, and I have known of people doing that. But we fixed hers, but we found a sending unit that was leaking. It was leaking really bad. Well, the leak went away, but the car would still go low on engine oil between changes with no visible leak, and it would seem it was going out the tailpipe. She didn't want to go to the trouble to try to fix that. A lot of times, you know, even Ford and GM, and I don't know about Chrysler, but Ford and GM both have this rule that even if a vehicle's under warranty, if it's not using more than a quart about every 1,000 miles, it's not anything they want to worry about fixing. Believe it or not, that's actually in their policies. We replaced a whiny leak power steering pump. I mean, a weak one. They didn't have good power steering. You know, we put the power steering pump on there, and she had it steering until the belt stretched out a little bit, and the bolts were at the end of their slots when we were trying to tighten the belt, and then you just couldn't tighten it anymore. So she had to get a belt that was a little bit shorter. You know, and these kind of things are fairly simple and straightforward. But even on the simplest jobs that we do, we still need to draw valid conclusions. You know, you can actually be looking at something really simple and make a silly mistake because you didn't think it through. You see. All right. So lack of power on a V6 Monte Carlo. This is one we did. After checking for fuel and air issues, we checked for exhaust back pressure and replaced the catalyst. There's a muffler shop guy that I know, that a pretty good guy. I mean, good mechanic, does good work. And whenever somebody comes in there with the idea that their exhaust is stopped up, now you can take a temperature gun, and you know if it's hotter on the inside than it is going out, then you got a pretty good idea that there's some clogging going on there. But that's not always 100% accurate. I've actually seen that lie to me. I've seen that it'd be hotter on the back side than the front side, and this one was one of those cases. But what we did was, you know, there is a tool you can fabricate with an 18mm plug, like what comes in those converters that don't have oxygen sensors in them. You got to screw a plug out, drill a hole. I've talked about this on another video. Drill a hole through it, tap some threads, put a brake bleeder screw in there, and you can make you a tool for hooking up where the oxygen sensor was. Well, this muffler shop guy that I knew, he would drill a 1/8 hole in the exhaust right in front of the catalytic converter. Now you can't do this on one of the catalysts that's right up there on the manifold. But if it's back there in the exhaust stream, drill a hole, and you put you take one of those regular fuel pressure gauges like that right there with a hose. We use one of those orange temperature resistant hoses, but you could use this because you're not going to be there for a second. Hold it up against that hole while somebody's in the car. They might get them to gas it a little bit or whatever. You're not supposed to have any back pressure at all in front of that thing. If you've got as few as 5 pounds of back pressure, you got an issue with that catalytic converter, and I've seen that too. But the long and the short of it is, this one here was clogged up really bad, and so we wound up putting a catalytic converter on it. And when you're putting a catalytic converter on there, if you can put an OEM style replacement on there, you're a lot better than you are with one of those universal ones. Now Walker makes some really good replacement catalytic converters that are typically pretty solid. You can put a catalytic converter on there that's cheap though, and it'll start throwing you codes because it won't store oxygen the way it should, and you'll have a PO420 code or whatever come back if you put a crappy one on there. But you need to put it on there the right way so there are no exhaust leaks and it's mounted right. And if that is almost a muffler shop job. We have done them over where we are. If you're cutting the muffler off, it's a whole lot better to do it with one of those high-speed saws, or the welding department over there at the college used to use a band saw, a handheld band saw to cut those things off. And then we would make marks around there so that we would know how that thing was indexed, so that when we put it back on, they would tack weld it, and then we'd bolt it up, see if it was going to fit, and then take it off, and they go weld it the rest of the way. All right, Go NoGo Test is the best. I always despised the test that wouldn't tell me the truth. We had an injector cleaning machine that had a flow meter on it when I was at Ford, and that doggone thing, you would flow test the injectors, and they would flow test a certain way, and then you would clean the injectors, and they would flow test the same way or worse, and the vehicle would run better, or they would flow test better and it wouldn't run better. So I just didn't like that because it wasn't a Go NoGo test, and I discarded that test for a while, even though that was a $2,000 machine. But of course it primarily had a pump and a tank, and it was fixed up with adapters so you could hook it up to the fuel rail and clean the injectors using that stinky ammonia smelling Motorcraft injector flush stuff. But you can take your meter, even a cheap meter, and put it on diode check, and you hook it here, and then you flip it around. You'll get a reading one way, you won't the other way. That's what it's supposed to read like. If it fails the test, the diode test, from going to this big battery post in the frame and then flipping the leads around, and you should get no reading one way and like 500 and something usually the other way. The point is, if it fails that, then you found your problem. If it passes that, you may still have another problem. It can pass that test and still have other issues in the alternator. So that's not a Go NoGo test unless it fails. If it fails, it's a valid set of circumstances. But you can't say, well, I diode checked the alternator, and so that means everything's okay. Because it can have problems with the brushes. It can have an open rotor coil. There's all kinds of stuff that can be wrong with it. The fan test, using a test light in series with a fan motor, is another Go NoGo test. I talk about this a lot. If it fails, you hook a light bulb. I actually like to get a test light and hook it to power and unplug the fan relay and you got to look at your schematic to make sure you're doing it right. Unplug the fan relay from the power distribution center and go to the post that goes out of the fan. That bulb should light up. You turn the fan through. If the light ever goes off, that's a go, no-go test. Because if that fan ever stops on that dark spot, it ain't going to run even if it gets power. So anyway, this right here is a little schematic I drew on paint on how you make that work. You just basically hook it up so that the light bulb in series with the fan. You can test a fan motor on the bench or any other kind of electric motor pretty much that same way if you can spin the thing through by hand. Power window motors are hard to do that with. All right. The fuel pump testing a fuel pump that way works too. If you go to, like on your Chevrolet pickups, you got that little prime terminal. And if you hook up to the outside of your battery with your test light and you go to that prime terminal with the tip of your test light, it should light up. Now I have gone there, found that thing dark on a no start, have somebody kick the tank. If it lights up, you got fuel pump issues and you got to replace the fuel pump. I did get thrown one time on that when I had a chalky connector, but I talked about that a 3 weeks ago. You can scope the fuel pump with an inductive current probe. That's a good no-go. The good fuel pump, when you scope it, will look like that. So how do you scope it? Basically, in order to get a nice reading like this on your scope, you've got to have an inductive probe, obviously. But you can't just run a jumper from the, unplug the relay. You can't just run a jumper from the power, from the common terminal to the normally open terminal to run the fuel pump. That'll run the fuel pump, but you won't really get a good scope pattern like that. So what you need to do is you need to take a piece of insulated wire and wrap it around and around and around and around and around. Every wrap multiplies that by another factor. So if you wrap it around and around and you got a coil of wire with 2 pieces sticking off and you run it through that coil and then you inductive current test the whole coil of wire where that current's flowing through there, you'll wind up with a really good signal that you can use. This will be a crappy fuel pump. This will be a good one. It's just the way it is. Unplug your relay and hook your little coil of wire, from here to here so that you're running the pump through your coil of wire and all the current's passing through there. You can catch a fuel pump early that's failing that way. That's gathering good data. Now sometimes you'll do a repair that needs to be done, but it may not be all that's wrong. I kind of talked about that on that Renault that I covered last week. You can find a problem that for absolute certain is a problem, but it could be not all of the problem. And you can think you've got one fixed when actually you didn't have. One example of that is if you fixed a vacuum leak that you found because you had fuel trim numbers, that were trending positive, then you can basically clear the memory so that you're back to zero with your fuel trims. Take your battery cable off, do a clear your scan tool, whatever you want to do. And after you've made your repair, fire it up. When it closes loop, if that fuel trim starts walking positive again, you're not done. That's how you verify your repair, is you recheck everything to make sure it's okay. All right, here's a simple example. Turning the key is supposed to start the car, but it doesn't. So what piece of information do we need to gather next? We hear a clicking noise from the starter with no operation. We notice that the instrument cluster lights are very weak. And so that's 2 pieces of data that we got here. We're listening, we hear that clicking noise, and then we also notice these lights on the dash are kind of weak. Okay, so here we go. We got 2 pieces of information, but is that enough? All right. What are my thoughts? This is our first step toward a conclusion, taking the data that we have and working our way in the direction of finding out what the truth of this matter is. Okay, so we have a dead battery? I don't know. Bad connection somewhere? Where are we going to start? It's really important to do this stuff in the right order, because if you bypass it and you do it in the wrong order, or you don't have a systematic way of going about this, you're going to have some issues. All right. Brush or wash away the corrosion on the battery terminal. This is an extreme example. And then basically you're going to check your battery voltage and see what it looks like. And let me back up and write that again, because it didn't, it wrote it so fast here. See that? All right, remove the terminals, test the battery. We're going to do that. You can get your little cold cranking out tester, test the battery, see if it's good. Sometimes you may need to put a little bit of a charge on the battery if it's weak, and that's important too. All right, so battery checks out fine after you charge it. Terminals are cleaned and reinstalled. Charging system's tested. The result is you got 12.3 volts and you're dropping while the engine is running. Okay, so that means we need to know what's the normal charge voltage is. 14.5 volts usually. If you don't have 14.5 volts and it's basically killing the battery as it runs. You know, you got alternator issues. This is a simple example. All right, if all this checks out, it's probably the alternator. Now you got to make sure that now this is a very simple, you know, one of the GM styles. Basically, you're going to have your charge light. You got to make sure on one of these old systems like this that the charge light comes on when you turn on the key. If the charge light doesn't come on, you're going to have some issues. You need to know if that charge light doesn't come on. You need to know why it doesn't come on. If the fuse that's feeding that charge light, and sometimes you'll have a fuse on, like on the 98 Rangers, there's a fuse that feeds nothing except the charge light and the airbag light. The other lights will still work on the dash, but I could pull the fuse on that and keep power from going through that charge light bulb to turn that regulator on, and it wouldn't charge. The other one, this one here, measures the voltage, the battery voltage, so the voltage regulator will know how much fuel to give it. But you got to have good power here, you got to have good power there that's equal to battery voltage, and you basically got to have 12 volts here. That you're probably going to need to measure that with a meter, because if you try it with a test light, you're going to half light that and half light your meter. And you also, the alternator's got to be grounded, obviously. You can do voltage drop tests on your charging system too. There's a lot of tests you can do. But typically when you get to this point, if you've gathered all your proper data at the terminals, most of them now just have one terminal. It'll be like an L terminal, and then or maybe they'll have two. But the PCM likes to control the alternator field on most vehicles nowadays. So find the truth. The detective or investigator must gather and analyze data in a way that their investigation leads them to the truth and its reality. You got to verify the no crank, verify weak voltage. This is the data we gathered. Battery cleaned and tested, okay. Check alternator connections, okay. Conclusion, replace alternator and retest. You get more data after you retest the alternator. But make sure you get a good alternator, not one of those crappy ones. You know, because if you get one that's a sorry alternator, and you know the parts house are probably not going to pay you labor to change it again. You know. All right. So if the investigation doesn't gather enough data, if the investigator doesn't gather enough data, whatever's done is a guess. You like people guessing? All right. If the investigator doesn't gather data in the right way, any repair performed may be done right, but still may not fix the problem. Usually, the battery would be replaced first in the scenario outlined, and the alternator would be replaced. But if there was a problem with the wiring because they didn't go deep enough to check the wiring, the alternator and the battery might have been replaced unnecessarily. All right, so when an investigator or a researcher comes to a false conclusion by not gathering enough data before forming the conclusion, that person has made what is known in the statistical research circle as a type 1 error. That's one of the two types of errors we're going to talk about today. Shotgun troubleshooting is expensive. All right, so the type 1 error, in this case, the truth remains undiscovered and the investigation has failed, and probably money and time has been spent that didn't do anything except spend money and time. All right, more work needs to be done. The 2007 Buick hard start, no start issue. We had this one here, was a Lucerne, is what it was that we worked on. And we verified fuel pressure. And it didn't always do this, it was intermittent. We verified fuel pressure, which remained solid even when it was starting hard. We found that when it wasn't starting, there was no fuel injection and no spark, but the crank sensor signal was consistent. So we always had a crank sensor signal. This was the no start side. We always had a crank sensor signal, but we didn't have a cam sensor signal, or we didn't have ignition, we didn't have fuel injection. So we didn't have fuel injection. So these three were missing. So it's like, you got to know a little bit about how all this comes about. Not all vehicles will fail to start just because they don't have a good cam sensor signal. Most of the time, on the Fords that I worked on for years, you could actually unplug the cam sensor and it'd throw you a 340 code, but that's all you got. It would crank and run just fine. On some of your CSFI Chevys, those darn things could be missing a cam signal, and they would bank fire the injectors and get horrible gas mileage, but they'd still run. So basically on this particular one here, the cam sensor was something that we figured, well, what we'll do with this one is throw a cam sensor at it, because it didn't cost very much anyway. It was a little bit of trouble to do it. But since we were losing the cam signal, and the cam signal, that Buick depends on the cam signal to produce the injection of the spark, or the injection of the spark. It's injection that spark. Alright, so we attempted to verify the repair by warming it up 6 or 7 times, shutting it off, restarting it. Previously it would exhibit the no start every time that way, even if briefly, and that kind of led us to believe that we had made a difference. There was a reason that we were led to believe that, though. But on this round of tests, the vehicle started normally every time. There was no time for a long test drive, but TJ took it on a long drive, parked it, and the no start happened again, and that's where we went after that. So based on this scope capture, we know our cam sensor, ignition, and our fuel injection are all gone at the same time. This was after replacing the cam sensor. Now, it didn't do it as often after we replaced the cam sensor. That can confuse you too, right? But think about what we did here. All right, here's the signal that we're getting from the cam sensor. This is a crank sensor. This is the ignition, and the fuel injection is coming from the PCM. All right, so basically, could it be this? Yeah, you know, could it be that? We know that we're not getting ignition. We're not getting ignition or this when we lose that. So this is probably going to be the cause rather than, you know, these are effects and that's a cause. This is what we found. That brown-white wire right there, and this is after we fixed it, but that brown-white wire was out of its loom enough so that that balancer had spun against it and had got into the copper. And we actually just got a brand new connector, you know, and we put it in the loom and we put it behind that plastic shield like it was supposed to be and made sure it was routed right. And that Buick was a done deal. And so that's the smooth thing about the Buick. But that one little chink in the wires, and just about all you guys have seen this. Now, a type 2 error is to reject the truth. Have you ever looked like that when you saw one coming in on the hook and you were just sure that you had fixed it right? Reject the truth and believe something false. That's what we might be tempted to do when a vehicle comes back we worked on because we missed something, and it's always best to avoid type 2 errors and give the customer the benefit of the doubt. Let's just say, well, maybe we missed something. Let's just look at it and see what happened. You know, maybe we had some kind of a part failure, right? So this 98 Camry with an oil leak, shop charged them $400 to put a pan gasket on it. They went on a trip, had to add a quart every 100 miles. Stopped in there where we were. It just so happened this boy was related to me, and he'd been making a trip from way up in Georgia. So we got this, found out that real common on these Toyotas, that oil pump, that O-ring behind that oil pump right there loves to leak. And it was, since it was running down there dripping off the pan, see, they made a type 1 error. They didn't get enough information to find out where the oil leak was really coming from. They just says, well, it's dripping off the pan, so that's where it must be. That's like when it's dripping off the bell housing, you assume it's coming from the rear main seal, when actually it's coming from a head gasket that's, you know, where the oil pipe going up to the camshaft has been breached. Seen that too. But there's paid researchers in today's academic and scientific communities who aren't really looking for the truth. They're getting paid to find what they're getting paid to find. And that's basically how that works. Now they're only interested in discovering what they're getting paid to prove, and they're looking to fabricate a predetermined conclusion. There's always an ulterior motive. When they discover some genuine scientific fact that refutes what they're trying to prove, they suppress the fact and ignore the data. We don't need to be doing that when we're working on cars, or we'll get in trouble and the customer's not going to be happy. All right. This is an interesting little blurb here, just this one slide. 100,000 molecules versus atmosphere. 35 molecules of that 100,000 are CO2. One of those 35 molecules is man-made. That's not worth spending $1 trillion a year, y'all. All right, in spite of the fact that the U.S. didn't sign the Paris Accords, the U.S. cut carbon emissions by over 40 million tons in 2017 alone, while China and India have increased their CO2, but that's not a big deal. Why? Because only 0.117% of CO2 is man-made, and CO2 is almost nothing when it comes to any kind of global warming. Water vapor is the most significant greenhouse gas. It always has been. This column right here, natural, the gray is the natural, the man-made is the purple. Only 0.001% of water vapor is man-made. So this is something that's happening naturally. Avoid both types of errors. In the business of troubleshooting and repair, type 1 errors are bound to happen. Anybody that has never had a type 1 error where they thought they had it fixed, but it wasn't, you know, that is one of the things that you need to be aware of, okay? We need to be careful gathering our data and avoid the type 1 errors. Gather the data as good as you can. Now, crazy as all get out. You know, a lot of these manufacturers, even Hyundai, when they're talking about their electric power steering, will say if you've got a problem with electric power steering, one of the procedures is replace it with a known good steering column. And how many times in the shop manual have you seen replace it with a known good module? That's the way that goes. When we do experience a type 1 error, we should be prepared to admit it and do what we can to deal fairly with the situation, and sometimes that may be costly, but a good name is difficult to earn and easy to lose. What's wrong with this picture? My buddy Donnie had his over here at his shop, and he found a bunch of these. Some of these rocker arms were, the stud was broke off flush, and the rocker arm was rattling around in there, and some of them, the push rod had punched all the way through the rocker arm like that. Somebody over-revved the crud out of this thing, I imagine, and floated some valves. That's the only thing I could come up with that caused that, because they had too much catastrophic damage on too many lifters, and too many rocker arms and all. Alright, so there's plain old errors. Sloppy work is included in this category. I don't know if you've ever seen anything like that, but I did know one guy that was a dealership mechanic, was working on a brand new Jeep, and there was an exhaust rattle, and he shoved a 2x4 in there to stop the exhaust rattle, which is obviously not acceptable in any shop. Alright, there's plain old errors. Sloppy work's included in that. Screws are sometimes left out, either because we forgot where they went, or we lost one that was hard to come by. When I used to have to pull those instrument clusters out of some of those Ford probes, there were 33 screws I had to take out to pull that instrument cluster out of there. I used to count those and to keep them in a magnet pen. Alright, sometimes, like, well, this situation here happened, and I actually covered that one time before. I was working on a V10 Ford van. You know how much fun those are to get to. And it had blown out one of the spark plugs. And they're down in that well. And the threads weren't totally destroyed so that they needed any kind of a bushing or a helicoil or anything put in there. But I did, put air through the intake so it was blowing out the plug hole I was tapping threads on, or you can put grease on your tap, that works too. I ran that 14 millimeter 1 1/4 thread pitch tap down in there and back out a few times. And when I screwed the plug in there, I wasn't sure if that plug was going all the way down to the point to where it was making contact on that bevel. It was a 99 E350 van. But when I put this Prussian blue on there, which you can buy it at the store, made by Permatex, and I screwed it all the way down, and I could tell when it seated because it smeared that Prussian blue. That Prussian blue is really good marking compound for all kinds of things. And these spark plugs right here were the devil to change, I'm telling you. That's a different set of spark plugs there. That's a joke, actually, by the way. But anyway, ever done this? Unless you're beside an interstate somewhere and just trying to get back to the house, it's best not to make this many connections here, because you can see all the heat that's been generated by the voltage drop by these crummy connections. That's a plain old error. And a type 1 error, to recap, is to avoid these, we need to gather sufficient data to reach a valid conclusion. We're trying to uncover the truth. Type 2, when we've gathered enough data, we need to let that data lead us to the truth. We don't need to reject it. I had this one guy that came to see me one day, back when Ford used to have these little motorized idle speed control motors on them, and I would measure the resistance of that idle tracking switch, and it should be a straight, dead short. With my meter read 30 or 40 ohms, I knew we were going to put an idle tracking switch on before we did anything else. And so I told the guy, and it was doing the kind of stuff it does when those idle tracking, they could make you stumble and all kinds of stuff. And I told the guy, I said, you're going to have one of these. They cost about $140. He said, can't I look for the problem somewhere else? See, I had already discovered something that needed to be done, and really it turned out that's all that was wrong with the car. He didn't like the price that he was going to have to give his customer, so he was trying to get me to come up with an answer that he liked better. All right, know the difference. Sometimes we think we got enough data and later find out we didn't. Sometimes you swear you checked enough stuff to where you got to the truth, then you find out whenever it acted up again that you didn't quite go far enough. Everybody's been in that boat. Think logically, know your stuff, gather good data. You need to know how to do that. Avoid errors of all kinds, and don't be a second-rate amateur. Being a second-rate amateur is really a nasty way to treat your customer. A lot of times, sometimes we get frustrated because the bills haven't been paid, and we've got to get this car out. And, I used to work on 4, 5, 6 cars at one time, and have to. My ideal way of thinking was you fix this car, you move on to the next one. You fix this car, you move on to the next one, and so on and so forth. But that's not the way it works in the real world. You're going to have to pull off this car and go on to this one. And I always loved it when I already had a customer waiting, and they would pull me off of that one and put me on another customer waiting. Then they would pull me off that one and put me on another customer waiting. But this is our world. And I just want to tell you guys how much I appreciate you watching, and I hope you got something out of this and it provoked a little bit of thought. No real lightning striking here, but appreciate your viewing, and I'll see you next time.